So we have completed one part where we studied beta and gamma function both. Now you must have certain doubts that, for example, I say that tau of 1 is equal to 1. Now this was some gamma function property. So you would say, yes, you told that tau of 1 is equal to 0 factorial and hence it will be equal to 1. But the question says why? So basically it comes from the definition itself. So what is the definition? We read that tau of n is equal to 0 to infinity e to the power minus x, x to the power n minus 1 dx. Now if I put n as 1, so n is equal to 1, we can say 0 to infinity e to the power minus x, and that is equal to x to the power 0 dx. So this will eventually become e to the power minus x with a negative sign. Why with a negative sign? Because e to the power ax is integrated as e to the power ax by a, where a is minus 1 here. And so therefore this will be tending from 0 to infinity. So basically it is equal to e to the power minus infinity minus e to the power, that is you write minus 0 0, both are one and the same. So therefore this tends to 0. Why? 1 by e to the power infinity is tending towards 0, so this is equal to 0, minus minus plus 1, so hence the answer will be 1. Now another part of it, if I say that, yeah, here we write tau of n can also be written as n minus 1 into tau of n minus 1, where n is greater than 1. So if I write like this, how is it possible? Again it comes by the definition itself of gamma function. So tau of n is 0 to infinity e to the power minus x, x to the power n minus 1 dx, and hence it can be integrated as x to the power n minus 1 e to the power minus x divided by minus 1, which ranges from 0 to infinity. Now how I did this? Basically you must know Euler function. So Euler, here there is some first function and there is some second function. So first function here will be x to the power n minus 1 and the second function will be e to the power minus x. So first function, integral of second function I have written. Now differentiation of first function, so this will be n minus 1 x to the power n minus 2 n minus 2. Now integral of first function again, so this will become e to the power minus x divided by minus 1 or dx. Again it ranges from 0 to infinity. So here the value will be limit x to the power, now there is some minus sign, so x to the power n minus 1 divided by e to the power x, and there is a negative sign here. So this will be from 0 to infinity. Again in this case if I take minus and minus sign, so this will be plus 1, and here it is left out x to the power n minus 2 e to the power minus x and dx, again which is equal to 0 to infinity for the limits. Now if I say x to the power n minus 1 divided by e to the power x for x tending to infinity, this will be equal to 0. Why? If n is greater than 1, so x to the power n minus 1 by e to the power x, limit n tends to infinity. Yeah, for n greater than 1, sorry, x tends to infinity, this value becomes 0, and again for x ranging from 0, so this will be equal to e to the power 0 1, so minus minus gets plus sign, and hence the value will be n minus 1. So here it will be 0 divided by 1, so this will be 0 plus n minus 1, 0 to infinity x to the e to the power minus x, x to the power n minus 2 dx, which is nothing but tau of n minus 1, and hence we say tau of n is equal to n minus 1 into tau of n minus 1. So in this case we can also say tau of n plus 1 can be written as n into tau of n. Now this will continue. If n is a positive fraction, this goes on, and I can write tau of n as n minus 1 into n minus 2, and this goes on n minus r into tau of n minus r, where n minus r is greater than 0. So again we can generalize one thing from here. If tau of n plus 1 can be also said as n factorial, for what? N as non-negative integer. N must be non-negative integer. So here, why it is so? So we can write tau of n plus 1 can be written as n into tau of n. We have proved earlier it can also be written as n into n minus 1 into tau of n minus 1. Again it can be written as n into n minus 1 into n minus 2 into tau of n minus 2, and this property goes on till when this becomes 3 to 1. Therefore hence it will be tau of n plus 1 can be written as n factorial. Let's see some of the question. So if I write the first question, say tau of 9 by 2. So you will basically say, since it is positive, you can write 9 by 2 into 9 by 2 minus 1, that is 7 by 2, into 7 by 2 minus 1, that is 5 by 2, 5 by 2, then 3 by 2, and then you will write tau of 1 by 2. Now what is this? See here, it will be 9 7 63, that is 63 into 15 divided by 16, and tau of 1 by 2 we have proved earlier that it is equal to root pi. So answer will be this. Again if I write tau of, say if I say you tau of minus 1 by 2, how would we approach? Now we know tau of n plus 1 can be written as n into tau of n. So basically tau of n can be written as tau of n plus 1 divided by n. So here if I say n is equal to minus 1 by 2, then this will be tau of 1 by 2. We'll say tau of 1 by 2. Again we can write tau of 1 by 2 divided by minus 1 by 2. So which is equal to minus of 2 root pi. Done. Similarly, we can write for tau of minus pi by 2. So how do we go for minus pi by 2? We can write it as tau of minus 5 by 2 plus 1, that is tau of minus 3 by 2 divided by minus 5 by 2, which is equal to minus 2 by 5. Tau of minus 3 by 2 can again be written as tau of minus 3 by 2 plus 1, that is minus 1 by 2 again, and here it will be minus 3 by 2, which goes up and is written as minus 2 by 3. So basically the value will be 4 by 15, and tau of minus 1 by 2 we have already find out minus 2 root pi. So answer is minus 8 by 15 root pi. Now till now I think you might have understood how to find the gamma function.